Welcome everybody. So this is going to be your chromatography lab that the students are going to do in class, but you guys can actually try this one at home. If you guys have any coffee filters, you can actually cut coffee filters into strips like this, okay? And then if you've got some markers at home, some Crayola washable markers at home, you don't want to use Sharpie because Sharpie actually is a permanent marker, but if you have rubbing alcohol at home, you can also use that in a cup. So all you would need is a cup, a marker, some coffee filters, and then you're going to tape that to your like a pencil or something like that and stick in the thing. So you'll get to see how we're actually going to do this in a minute. So the basis behind paper chromatography, it is a way to look at complex mixtures by separating them into their components, okay? So this is the paper that you'll use. Remember, in Google Classroom, it's not going to benefit you to just go to the assignment and try to do the assignment. Remember, you have to use my Google Interactive Slideshow because all of my videos are going to be embedded in there. So this video that I'm showing you right here, when you get ready to go answer these questions in the assignment, you're going to have trouble answering the questions because you're not watching the video as it's going along, okay? So make sure you do that. Now, criminal investigators use this technology to identify substances such as drugs, blood, ink, and other fluids. So when you watch those CSI shows, this is some of the stuff that they're doing. You can actually even use chromatography, thin layer chromatography, to detect lipstick shades. So like if there's a crime that was committed, they can actually get lipstick from a house, and then they can, if someone was drinking a glass, they can get the lip prints and they can get the type and brand of lipstick that that person might use. So that's kind of neat. They can also, when someone writes a note, they can see where the pen that they use, what kind of pen they used on there. So here's how it works. Because molecules in ink and other mixtures have different characteristics such as size, charge, and solubility, they travel at different speeds when pulled along a piece of paper by a solvent. In this case, we'll use water. If you're using a Sharpie, isopropyl alcohol would be your solvent. For example, many black inks contain several colors. When the water flows through a word written in black, the molecules of each one of the colors responds differently to the mobile phase, which is the solvent, and the stationary phase, which is the paper. So the paper is going to be your stationary because it's not moving, and then the water is traveling up the paper, so that's why it's your solvent, because it's actually moving and separating the mixtures, okay? Many common inks are water soluble, and they spread apart into their component dyes using water as a solvent. If the ink you are testing does not spread out using water, it may be permanent ink. In such cases, you will have to use a solvent such as rubbing alcohol. Now, your engineering connection. A firm understanding of solutions and mixtures and their components is essential for environmental engineers, whose challenge is to prepare solutions to monitor and test groundwater for contaminants, and to develop remediation processes that separate pollutants from their water solution. So your drinking water. So environmental engineers are very diligent in making sure that you don't have stuff in your drinking water that could contaminate it and poison you or make you very, very ill. Okay, so now I'm going to flip over. This is our lab handout, so you'll follow along with the lab handout, and I'm going to kind of show you how we're going to set this up. So what we have here is we have 4 beakers, and you could use a cup at home, like a plastic cup or anything like any kind of cup. And I put water in the bottom of this cup because all the markers I'm using are water soluble. Now, what's also interesting is companies. They can't, when companies have patent on different recipes, they cannot use the same recipe and then go and sell that marker. So Vis-a-Vis, which is a wet erase marker, or wet erase type marker, that is used like on overhead projectors and things like that, but it's a different company. So their actual mixture for brown is going to be different than Crayola's mixture for brown because they're 2 different companies and they can't use the exact same mixture. So when these separate, you're actually going to see an interesting distinction between the same color but 2 different manufacturers. So we're going to do both brown and black and show you and compare the differences between Crayola and Vis-a-Vis, okay? So how you do this is you're going to take your paper like this, and you're going to go probably about 1 inch above, and you're going to put a really big thick line on there, And you're going to do that on every paper, okay? Every one of your papers, and use a different marker. So now we're going to use Crayola brown. Then we're going to do our black, okay? All right, mark all of your papers first, and then you're going to take it, okay, and you're going to tape it. And you can just use the marker that you use to write on, and make sure when you put it in here, I'm going to show you guys. So when you're taping this on, you want to make sure just the tip of your paper is touching, not the ink, because remember, these are water soluble. So if you stick the actual ink mark in there, it's actually going to bleed off the paper, and then it won't work, okay? So as you can see right there, here I'll hold it up and show you, that's how mine looks. And see how just the edge of it is touching the water, okay? So I'm going to set that back, and now I'm going to do my next brown. Do the same thing, make sure that's touching the water, okay? All right, and now I'm going to tape that one on my next pen, okay, like so. Set that one back. Let's do the next one, okay. All right, got that one on there, taped, that one's moving, and now let's do the last one, okay. So here's what I'm doing. I'm comparing vis-a-vis with Crayola, okay. Actually, I don't want to do that, but all right. Okay. Now let me line these up so you can see them, okay. All right. So now you can see it's traveling up like so, and then as the water is traveling up, it's going to pull those mixtures apart and separate them into their component colors, okay? So you'll just watch. Now, so I've done this a little earlier to show you. See how you can already see this one's starting to separate. Now, here's the cool part. That's the same marker, okay, with it separated. And what is crazy about this is these two are the same color. Fascinating, isn't it? They both made brown, but they look incredibly different from each other because they're made by two totally different companies. So those are my two browns, and these are my two black colors, okay? And like I said, as you can see, all right, complete difference. And what do you notice about the vis-a-vis? Okay, it's a wet marker, and notice how big the band is of separation on the brown and the black compared to the Crayola. What do you know about that? Well, Crayola probably waters down its mixture a little more than the vis-a-vis. Probably because the vis-a-vis is a wet erase marker and you use it on an overhead projector. So those colors need to be a lot more vibrant. But if you go to the store and you try to buy vis-a-vis, they are actually way more expensive than Crayola. Probably because they're using more pigments in their colors than Crayola. So you can see these are kind of watered down, right? So there's an example. So now in your paper, it's going to say, how did the appearance of the filter paper change during the procedure? So as you can see, if I were comparing these, you see it's going to travel. So you can answer that question there. What evidence is there that the ink is a mixture? And then how could you use this procedure to identify an unknown type of ink? And then number 4, how might the ability to separating solutions into their components be important to environmental engineers looking into water quality issues? Okay, so I'm not going to answer those for you because those are yours to deal with. But as you can see, okay, I'll just hold them up real quick. Here's the comparison between Crayola brown, and vis-a-vis brown, okay? And then here's a comparison of vis-a-vis black and Crayola black, okay? See the difference between the two, all right? Now, You will once you write out your explanations, you will then turn that into Google Classroom. Hope you guys have a great day.